Hello and welcome to another Matlab tutorial. In this tutorial I'll show you how you can create 3D plots in Matlab. I'll start by showing you how you can make contour plots, then how you can use the quiver function to plot, for example, gradients of functions. I'll show you the surface function and, after all, the plot 3. And by the end of this video I'll show you how you can make an animated plot in Matlab. So to start this tutorial I'll start by creating a mesh for x and y using the function mesh grid spanning from -2 with increments of 0.1 to 2. So this function will essentially create me a square grid for x and y, both spanning from -2 with increments of 0.1 to 2. I'll show you in a minute what this is. Then I'll define a z function that will depend on x and y, and I've created a function here previously, so I'll just copy it here. And to create the contour plot, I'll type contour of x, y, z, and the number of lines I want to plot. So let's choose, for example, 10 lines. Okay. I'll save the script and I'll run the function. Oops, forgot a comma here. So I'll run it. And as you can see, it created me a contour plot that has 10 lines. Now I could, for example, change the color of the contour plot by typing, for example, color. Okay, so this will be a general input for any plots you want to make. So this will make me a black contour plot like this. All the lines are black now. And now let's plot the gradient of z on top of the contour plot. And to do this, I'll just have to calculate the gradient of z, u, which is the derivative of z in respect to x, v, which is the derivative of z in respect to y, equals to gradient of z, and I'll define the step here, which will be 0.1, 0.1 for both derivatives. So this will be an approximate derivative. However, if z was a symbolic expression, you could compute the gradient analytically. Now we need to make a plot of the gradient with arrows, and to do that I'll use quiver of x, y, u, and v. I'll remove this here so you can see the contour lines better, and I'll add a null one here so I can plot this on top of this graphic. I'll save the plot and I'll run the function. As you can see, it still has the contour lines, but now it has arrows indicating the direction of the gradient. So I'll zoom here so you can see better what I'm talking about. And you could also change the color of these arrows, as I did before. I'll show you it. So I could use the command color, and let's make, for example, red arrows. I'll save it and run it again. And as you can see, the arrows are now red. So this is what I wanted to talk about contour and quiver function. And now I'll talk about the surface function. So I'll comment this. And to do the surface function, I'll just type surf of x, y, and z. And let's see what it gives us. Okay, as you can see, this is the function we were plotting before. I can use this rotate 3D button to rotate the figure around. And now I'm going to show you how to change some parameters. So the first modification I'll make to the code is type s equals to surf of x, y, and z, and you'll see in a minute why. So I can now come here and see what the variable s is. So it tells me that s is a surface with the following properties. Now let's try to change some of these properties. Let's try, for example, the face alpha. So s.fface alpha equals to 0.5. So let's change it to 0.5. Now let's see it here. As you can see, it is now more transparent, like this. Let's change now s.edge color equals to interp, like this, and it will interpolate the colors on the edge. Now let's watch it again, and as you can see, the edge of each grid has its color changed now. And I could also eliminate the edge at all by using the command s.edgeColor equals none. And as you can see, now there are no edges. So now I'd like to give you an example on how you can plot a 3D line in 3D space. And to do that, I'll type t, and I'll define the variable t. It could be, for example, time, going from 10 to minus 0.01. So I'll create essentially a vector backwards that will be ranging from 10 steps of minus 0.01 all the way to 0. And then I'll define x as t times sine of t and y as t times cosine of t. And for the z value, I'll use x squared plus y squared. Now, to plot the 3D line, I'll just type plot 3 of x, y, and z. And I'll run the script so you can see the figure. And as you can see, it created me a 3D spiral like this. Now I could also use other arguments to make this plot better. For example, if I wanted a thicker line, I could use the command line width, and for example, let's double its width. So I'll type 2, and let's say I want a green color, so color, oh, forgot the apostrophes, and let's say green, so G, and let's run the script again. And as you can see, now the color of the spiral is green and it has a thicker line. I could also use the command grid on to turn on the grid, and as you can see, now it has a grid, so it's easier to see. Now I'll give you a quick example that you can do to create an animated plot by using the knowledge I've just given you. And for that I've created the following script. And let's walk through it so you can understand it. So here I will make a surface, as you can see. I've got a surf here. I'll define first a mesh grid that this time ranges from -10 with steps of 0.5 to 10 for x and y. And the function will be essentially a 3D parabola. After that, I'll create the surface and put a hold on command. And after that, I'll change the face alpha parameter to 0.3 and the edge color to none, as I've shown before. And then I'll make a deanimated spiral. So essentially this script will draw an animated plot of, for example, a sphere going down this parabola. So I've created a vector t that will be time ranging from 10 with steps of minus 1 over 30 to 0. I've created x and y as before, z as before. And now let's analyze the for loop. So for I equals to 1 to length of t minus 1, this is important. And then for each iteration, I'll have a pause command of 1 over 30 seconds. And then a plot 3 of x that will range to the current step to I plus 1. So that's why it is important to have the minus 1 here. So it will just draw a line from the previous x to the next x. The same for y and z. Then I've had some parameters like before. The line width equal to 2 and the color equal to black. Now I'll run the script so you can see the spiral. And as you can see, it is drawing an animated plot of a spiral. This is everything I wanted to talk about in this tutorial. Thank you very much for watching, and hopefully I'll see you in another tutorial.